Okay, today we're going to solve another triangle using law of cosines. We're looking for the measured angle y if we know that the three sides are xy 28, xz 25, and zy 27. So they're pretty close in size. It's an equilateral, close to an equilateral triangle. It doesn't really matter. You just draw any old triangle. It's just a representation. Label the sides. These are capital letters for the angles. And of course, opposite the capital letters would be a small y. Opposite the small x, or the large X, would be a small x for the length of the side. And the same for z, would be a small z. So side xy is right here. So that would be z. So that's going to be 28. xy, yep. So xz down here is 25. So that means y is 25. And zy is 27. All right, so we're asked to find the measure of angle y. So that's what we're looking for. Remember, the law of cosines, because we're using a triangle that is side, 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 the law of cosines, the law of sines will not work because you don't know any angle. All three of your ratios, you'll have an unknown in each one of them, so it can't be solved. If I'm looking for this angle, I must start with the side opposite that. So I'm going to start with y squared is equal to z squared plus x squared minus 2 times z times x cosine of that angle y. So that's why we have to use the side opposite to begin with. All right, so we're just going to set that up. 25 squared is equal to z squared. Z is 28 squared plus 27 squared minus 2 times that 28 times 27. And multiply that by the cosine of angle y. All right, well, 25 squared is 625. If I take these two, square them, and then add them together, that comes up to 1513. Minus 2 times that is 1512. And cosine of y. All right, so if I subtract that over, that gives me a negative 888. And that's going to be equal to the negative 1512 times that cosine of y. All right, we've got to solve for the cosine of y and then take the inverse cosine of what we get. So we're going to divide by that negative 1512. The cosine of y is equal to positive 0.5873, 0.5873, and that's just rounded to 4 decimal places. Again, do not take that out of your calculator. Just do the inverse cosine of what you have in your calculator, and you'll get the closest approximation for your angle y, which I got to be 54.03. So rounded to the nearest tenth is basically just 54. So the measure angle y is 54. That's all we were asked to find, but let's go ahead and solve the triangle, which means I got to find the other two angles. So I'm going to use the law of sines for that, because remember, you only use the law of cosines one time in a problem. After that, you can go right back to the law of sines, because you will have a ratio now of side y to the sine. That's not side y. That's angle y. Come on, give me an eraser here. So side y is 25 is to the sine of 54 is equal to, and we can find either side. I'm just going to go ahead and find x. So side x, 27, is to the sine of x. So solving for sine of x, I'm going to multiply up here. So the sine of x is equal to, then I got to divide by 25 and multiply by the sine of 54. And if I do that, I think I came up with the sine of x is equal to a 0.8737, blah, blah, blah. Inverse sine of both sides, I'll find my angle to be rounded to the nearest tenth, 60.9. All right. All we got to do is find one more angle. And when you're looking for an angle after you know the first two, of course, you're going to say Z, or really the measure of angle Z, is equal to the total of the triangle minus the other two added together, 60.9 plus your 54. So the measure angle Z is equal to 65.1. And that's how you use the law of cosines with your side. All right, keep the questions coming on Google Classroom. Good luck on your AP exams. Keep asking those questions.